Trigonometric form of a complex number. We know that complex numbers are written in the form a plus bi, so we're going to let z represent our complex number a plus bi. If we want to write that in trigonometric form, we're going to rewrite it in the form z is equal to r times the quantity of cosine theta plus I sine theta. So obviously we can see the relationship that A is going to be represented by R cosine theta and B is going to be represented by R sine theta. But what you'll want to remember for all of the questions that we do is the computation involved in R, finding R and finding tangent of theta or theta. So R is the square root of A squared plus B squared, again from our original complex number, and tangent of theta is going to be B over A, and so obviously we're going to have to use an inverse trig function to figure that out. So let's take a look at our first practice, and again we're focusing on these equations on the screen. So we have the trigonometric form of z is -2 minus 2 radical 3i. So that means that A is -2 and B is -2 radical 3. Those are the values that I'm going to use in these functions. So first I'm going to find R. R is -2 squared plus -2 radical 3 squared. Well, -2 squared is 4. Remember, when you square -2 radical 3, it's -2 squared and radical 3 squared. So this guy turns into 4 and this guy turns into 3 because the square root and squared are inverses. So that's what gives me the 12. So the square root of 4 plus 12, or the square root of 16, which gives me 4. So that means R is 4. That gave me the 4 or R value for my new trigonometric form. Now I have to find theta. Theta is going to be B divided by A. So in this case, that's -2 radical 3 divided by -2, which reduces to radical 3. This is where being familiar with the unit circle comes into play. So we're looking at where is tangent, or y over x, equal to radical 3. Well, that's going to be when the numerator is radical 3 over 2 and the denominator is 1/2. And that occurs at two places, at pi over 3 and 4 pi over 3. So here's the trick. Only one of these is going to be correct. So I have to go back to my original complex number and say, if that was -2 and then -2 radical 3, that's going to be down here in the third quadrant. So the third quadrant corresponds to the 4 pi divided by 3. So that's the theta that I'm going to use. So even though this is true, tangent of theta is true when theta is pi over 3, it doesn't represent the original complex number that we began with. So pi over 3 doesn't work. So now that I have that, I'm just going to plug in the values. So my new form, my trigonometric form, is using 4 as R and then 4 pi divided by 3 as theta. Here are two questions for you to try. One is exactly like we had on our last example, and the other is going in reverse, and we haven't done that together, but I want to challenge you to do that on your own. So press pause. When you're ready, press play to see how you did. So for the first question, again, I'm going to start with R. If you need to write out that A is 6 and B is -6, you sure can. R would be the square root of 6 squared plus -6 squared, which is radical 72. You can turn that into 6 radical 2 or leave it as radical 72. Later, you'll see that when we're finding nth roots, I'm not going to mess with trying to reduce the radical. So we have R is 6 radical 2. We have theta is, tangent of theta is B over A, or -6 over 6, which is -1. Again, now we ask ourselves, where is y over x equal to -1? And that's going to be when the numerator is radical 2 over 2 and the denominator is radical 2 over 2, and one of them is negative. So either the numerator is negative or the denominator is negative, but not both. So where does that occur? Again, unit circle. If you're not sure, get your unit circle out. And I have 3 pi over 4 and 7 pi over 4. But my original point, 6, negative 6, was in the fourth quadrant. And so I need to use 7 pi over 4 because that is also in the fourth quadrant. So then rewriting my solution, I have z is equal to 6 radical 2, and then times the quantity of cosine 7 pi over 4 plus I sine 7 pi over 4. Now let's see if we can go in reverse. We can see that we already have it written in standard form, and now we want to go in reverse to write this in trigonometric form. How are we going to do that? Well, the first step is to say, what is the cosine of negative pi over 3, and that's 1/2. What is the sine of negative pi over 3, and that is negative radical 3 over 2. So that's helpful. Now we have to look at using 2 radical 2, which is our r value, already out front, and then I'm replacing cosine of negative pi over 3 with 1/2, and I'm replacing sine of negative pi divided by 3 with negative radical 3 over 2, and then I'm simply going to distribute. So I get radical 2 plus radical 6i. One thing I want to point out before we move on, it's very easy to confuse when your values are written like this. Just know that I value is not ever going to be in the radical. So the reason that they're writing it at the end rather than the beginning is it is customary when you're writing a complex number, a plus bi, it's customary to write the I at the end. So even if it looks like this, that is not radical 6i. We're not going to have an I inside the radical. So they're just writing it to the right because that is the correct way to do it. Let's now take a look at some operations with complex numbers. So we can find the product and we can find the quotient of 2 complex numbers. And their formulas are fairly straightforward. We're going to be multiplying the r values for a product and adding the theta values, or dividing the r values for a quotient and subtracting the theta values. So let's take a look at how we can work through this together. Let's begin with the product. So if I'm finding the product of z1 and z2, I'm going to start by taking 3 times 4, so that's r1 times r2. And the theta value is going to be pi over 3 plus pi over 6. And again, use your brain rather than your calculator. How can I add these together? Well, I could multiply 3 by 2 to get 6. So if I multiply the denominator times 2, I take the numerator times 2. So I get 2 pi over 6 plus pi over 6, which is 3 pi over 6, which is pi divided by 2. So my r value is going to be 12, 3 times 4, and my theta value is going to be pi over 2. So that's how I'm going to find the product. Notice now I have 12, and then cosine of pi over 2 is 0, and then I have sine of pi over 2 is 1, or 1i, because we have the I out front of the sign, and that gives me a solution of 12i. Using the quotient, I'm going to take 3 divided by 4 instead of 3 times 4. So 3 divided by 4, and now I'm going to be subtracting these values. So 2 pi over 6 minus 1 pi over 6 gives me 1 pi over 6. And that's going to be my theta value, is pi over 6. So now I have 3/4 cosine pi over 6 plus I sine pi over 6. Notice I'm just evaluating cosine and sine at pi over 6 and then distributing the 3/4 to get my final solution. Before we move on to squares or cubes of complex numbers or powers of complex numbers, I do want to point out another way to think about the product. So we know that we can think about the product, and yes, there's a lot going on, so I'm going to kind of walk through this with you. Let's think about the product of z1 and z2 written in another way. So if z1 is this equation, I can rewrite z1 as 3 times the cosine of pi over 3, which is 1/2, and the sine of pi over 3, which is radical 3 over 2. And then distribute the 3. So that is the component form of the vertex that represents that complex number. Then I can find the magnitude of z1 to be 3. I can repeat that process for z2 and find the magnitude to be 4. Now the tricky part here comes with, is it 12 or is it 12i? So we have to add the angles together, and we found already that that was pi over 2. Pi over 2 is 90 degrees, so that lies on the imaginary axis. So that's what tells me it is 3 times 4 or 12i rather than just 12. Let's now take a look at the powers of complex numbers. So I could use the product rule that we just determined to take 2 minus 2 radical 3i multiplied by itself, and I could do it 9 times, but that sounds like zero fun. So let's not do it that way. Instead, let's think about using DeMoivre's theorem that says all you have to do is put it in the correct form first, because obviously this is not in this correct form. This is in just a complex number form. So I have to write it in the correct form first in a polar equation, and then I have to use this that says simply take r to the nth power and take theta multiplied by n. So we're going to begin this question like we began our previous questions. I need to find r and I need to find theta. So again, a here is 2 and b here is negative 2 radical 3. So now to find r, I'm finding a squared plus b squared and then the square root, which gives me radical 16 or 4. To find theta, I'm taking tangent of theta is equal to b divided by a, which gives me tangent of theta is negative radical 3, which means I'm choosing between 2 pi over 3 and 5 pi over 3, but my original point would have been 2 negative 2 radical 3, which is in the fourth quadrant, which is why 2 pi over 3 is out and 5 pi over 3 is in. From here, I'm just going to write it in the correct format first, and then I'm going to use DeMoivre's theorem. So I haven't even used DeMoivre's theorem yet. I've just rewritten it in the correct format, which is 4 times the cosine of 5 pi over 3 plus I sine 5 pi over 3. Now I'm going to use n as 9 because I'm finding this to the 9th power. So now I'm taking 4 to the 9th, and I'm taking cosine of 5 pi over 3 times 9 and 5 pi over 3 times 9 again for sine. And then remember, this would be 45 pi divided by 3, which is 15 pi. Now, of course, I can use 15 pi, but remember that 15 pi has a reference angle of pi. So when I wrote it, I just wrote it as pi, because that's essentially what I'm doing is I'm subtracting multiples of 2 pi. So I subtracted 14 pi to find pi. But if you had 15 pi here, that is just fine too, because obviously you're going to get the same solution. And so what I end up with is cosine of pi, which is 0, and sine of pi, which is negative 1, and I end up with negative 262,144. Instead of finding the power of a complex number, I can also use DeMoivre's theorem to find the root of a complex number. So instead of taking r to the nth power, I'm going to take the nth root of r. Instead of taking theta times n, I'm going to take theta divided by n. And the difference here is I need to use plus 2 pi k, where k varies from 0 to n minus 1. And what that means is if I'm finding, say, 3 cubed roots, well, that means n is 3. So when I'm doing this question together with you, I'm going to let k equals 0, k equals 1, And because n minus 1 is 3 minus 1 or 3 minus 1, which is 2, then 2 is my last value that I'm going to use. So let's take a look. The first thing is I have a complex number and it is not written in polar form. It's not written with cosine and sine. So let's do that first. So to do that, I'm going to use the same steps that we've followed before. I need to find r and I need to find theta. So r is 6 squared plus negative 6 squared, which is 72. And you'll notice on this one, I'm not going to turn that into 6 radical 2, and you'll see why in just a moment. For theta, I've got negative 6/6 or negative 1. So because negative 6 would be down here in the fourth quadrant, I'm using 7 pi over 4 and not 3 pi over 4. So the first thing is that I would rewrite z as the square root of 72 and then cosine of 7 pi over 4 plus I sine 7 pi over 4. Now I'm going to use DeMoivre's theorem. So up to this point I haven't used DeMoivre's theorem yet. I've just been talking and doing stuff that I already knew how to do. So now I'm going to let z sub k, where k is going to be replaced with 0, 1, and 2 in a moment, z sub k equals the nth root of r. Now this is why I left this as the square root of 72, because if I'm going to take the third root of the square root of 72, that turns into the 6th root of 72. And that's why I didn't turn it into 6 radical 2, because that's just a nightmare. So I'm going to leave it 6th root of 72. And then it's a little bit messy the way I'm writing it. I'm writing as 7 pi over 4 plus 2 pi k divided by 3. Because again, n is 3, and I did that for both. So what I'm going to do now is, for clarity, I'm going to rewrite this 3 times. Once where k is 0, once where k is 1, and once where k is 2, and then I'm going to actually work out the values. So for k is 0, and again, you can disregard this part for just a moment. We have the 6th root of 72, and then we have the cosine. What we're doing is we're replacing k with 0. So 2 pi times 0. So really I just have 7 pi over 4 divided by 3, which is 7 pi over 12, and that's where this value came from. Now to find this, I just used my calculator. I took the cosine of 7 pi divided by 12, and then I multiplied that by the 6th root of 72. If you're not sure how to do the 6th root in your calculator, remember you can always just put 72 to the power of 1/6, and that's the same thing. And you should get negative 0.528 plus 1.970i. And then I did the same thing, letting k equal 1. So now I'm adding 2 pi, which 2 pi divided by 3, it kind of gets a little bit tricky. So what I did was I actually added it to the 4. So I said 7 pi over 4 plus 2 pi. 2 pi would be 8 pi over 4. So that's 15 pi over 4, or now divided by 3, 15 pi over 12. So that's really the worst math. Once you know how to plug things into your calculator, you got it. So then I get negative 1.442 minus 1.442i. And then again, I'm doing the same thing, now replacing k with 2. So now I'm taking 7 pi over 4 plus 4 pi. 4 pi would be 16 pi over 4. And then adding those together, I get 23 pi. And then we can see I've got all of my values. And interestingly enough, if you are to graph these, this is what the graph looks like. With the circle, the radius of the circle is the 6th root of, not the 6th root, I'm sorry, the square root, nope, the 6th root of 72. I have one question for you to try on your own, and that is to find the 4th roots of 1, which might seem a little bit tricky, but I have given you the hint that you would write that as 1 and then cosine 0 plus I sine of 0. So press pause, try this question on your own. When you're ready, press play to see how you did. So again, I'm going to write this as z sub k and then the fourth root of 1, and then cosine of 0 plus 2 pi k over n, and sine of 0 plus 2 pi k over n, and that gives me a 1 because the fourth root of 1 is 1. And then 0 we don't care about, so really we're looking at pi k divided by n, and that is the general form that I'm going to use. So now I'm letting k vary from 0 to 3 because I'm finding the fourth roots, and 4 minus 1 is 3. So notice I've just got 0, 1, 2, and 3. The math is pretty straightforward, so once I know what I'm doing, I'm just using my calculator to find the values. So z0 is 1, and then pi over 2, and then 1, and then 0. Coming up next, we have Chapter 7, Systems of Equations and Inequalities.